Number 5, write a function g of x described by the transformations of the graph. Sorry, I gotta reset my timer. Of the graph of f. So we have f of x equals x. And we want translation 5 units to the right and then a reflection on the y-axis. So remember, when we're moving things back and forth, it is f of x minus h. And in this case, it's 5 units to the right, so it's x minus 5. And when I put x minus 5 in for x, then I have just x minus 5. Okay, so it goes to this. Then, it's a reflection on the y-axis, which means that I have f of negative x. So now I'm going to put a negative x in for x. And I rename it g of x, and this is going to be negative x minus 5. I wish I would have done it this way. I hate writing across this way. Okay, so this one, vertical shrink by 1/2. This is when we have a times f of x. And in this case, a is 1/2 times f of x. So if I multiply this whole thing through by 1/2, okay, remember I can't distribute inside the absolute value sign. It's just going to be this 2 and this negative 6. So when I distribute this 1/2, I get x plus 1 minus 3. And then it's followed by a translation 3 units up, which is f of x plus k, or f of x plus 3. Well, this is my new f of x, I guess you could say. So now it is x plus 1 minus 3, and then up 3. So g of x is x plus 1. All right, x squared, translations 4 units to the left. Again, we have f of x minus h. H is negative 4, so it's going to be x plus 4. And when I plug that in for x here, I'm going to have x plus 4 squared. And then followed by a reflection in the x-axis. And remember, that's when we just negate the whole thing. All right, we throw a negative in front of the whole function. So for this, g of x equals negative x plus 4 squared. And then the last one of these, x squared plus 3, I'm going to stretch it by 5. So that's a times f of x. So 5 times x squared plus 3 gives me 5x squared plus 15, followed by a translation, right, of 15 units down. This is a vertical translation. So I'm going to subtract 15. So g of x equals 5x squared. All right. Our next problem. Okay, solving systems. Number 9. So I'm looking at this and I've noticed that I've got some y's in here that can cancel each other out. I've also got this 3z that can cancel itself out. But I think I'm going to go with the y's. So I'm going to take the first two. And if you look close too, you can see that the x's are going to be eliminated. So if I take the first two, negative 4x minus y plus z equals 14, and 4x plus y minus 3z equals negative 22, okay? The x's are actually eliminated. That's not what I was going for, but they're eliminated. So is the y. So I'm left with negative 2z equals negative 8. So that's kind of nice. I'm already given z, and I'm going to ignore this for now. So here's my z is, oh, I didn't write it down. Z is 4. Okay. So next, I think I'm going to do the first one and the last one. Actually, no, I see something else. I'm going to do the second one in the third one. So I've got 4x plus y minus 3z equals negative 22, and negative 3x minus y plus 3z is 21. Now when you look at this one, I have the same situation as before, but this time instead of my x's being eliminated, I've got y and z. So this gives me x. These are eliminated. Negative 22 plus 21 is negative 1. So this is nice. So now all I need to do is plug this back into one of these equations, and I'll get y. So negative 4 times negative 1 minus 1 plus z, which is 4, equals 14. So 4 minus y plus 4 equals 14. This is negative y plus 8 equals 14. Negative y equals 6, and y equals negative 6. So this is the answer to number 9. And you may have done that a different way. There's so many different ways you could do it, but that is the final answer. And I'm going to do the next one on the next video.